So jar contains 2 red items, 1 blue item, 1 green item, and it's a 2-draw experiment. So we have to remove 2 items. So first of all, draw this information on a tree diagram. So we know the first option is it can be red, it can be blue, or it can be green. That is the first choice. Now once you have taken, now you have to take another one. So the next one can be a red, can be a blue, can be a green. Now if you've taken the blue at first, the next one can be a red, can be a blue, can be a green. At first, if I've taken a green, it can be a red, it can be a blue, and it can be a green, red, blue, green. So this is the tree diagram. This is spreading out. That's what happens. Now we have to fill this up. So this is 2 out of 4 is the probability of red. Now if you have 1 red, the next red is going to be 1 out of 3. If you have blue, it's going to be 1 out of 4. If you have green, it is going to be again 1 out of 4. Now if you have a red at first, the next one to be blue is again 1 out of 3 because there is only 1 blue. And if you take a red and the next one to be green is again 1 out of 3 because there is only 1 green left. Now since there is only 1 blue, if you take out a blue, the probability of getting a next blue is 0 because there is no other blue left. It will be 0 out of 3. If you have 1 blue, the next probability for being a red is 2 out of 3. If you take 1 blue, the next one to be green is 1 out of 3. Now if you take 1 green to get another green, that probability is 0 out of 3 because there's only 1 green and you have already taken it. There's only 1 green. And when you take 1 green, the next one to be blue, that is going to be 1 out of 3. And if you take a red, that is going to be 2 out of 3. So that is going to be the probability. So for these. So the next one, question number B is, find the probability that it can be a blue, a green. So find the probability that a blue and a green are drawn from the jar. So a blue and a green, if you take a look at all the possible permutations, so it can be red, red, it can be red, blue, it can be blue, green. So this is one of the things that we want. So blue, green. It can be blue, red. It can be blue, blue. It can be blue, green. This is actually red, green. This is red, green. So blue, green is what we want. It can be green, red. It can be green, blue. This is also what we want, green, blue. And it can be green, green. So this is a sample space, every possibility, so that we can have. So the question was, find the probability that a blue and a green, we can have that. So this is going to be green, blue, or blue, green. So 2 possible permutation. So if we take blue, green, that will be 1 by 4 multiplied by 1 by 3, and permutations of the same probability, so into 2. So that is going to be 1 by 6.